Hello, everyone. Welcome to our second lecture about cybersecurity. So in this lecture, we will briefly recap some terminology from previous lecture, for example, cyber attack, cybersecurity, and then we will talk about a model in cybersecurity, which is called CIA triad. I also mentioned this briefly in the previous lecture. In this model, we have three angles. One is called confidentiality. The other one is integrity, and the third one is availability. We will talk a lot about this. And we will talk about different mechanisms actually aim to provide us with confidentiality, integrity, and availability. And they are called authentication, access control, and using cryptography to provide these properties. So let's go to this lecture. So first, let's briefly recap some terminology. So we are always connected through our computers or mobile phones or household devices to internet. And because of this connection to the outside world, it is possible that attacks can happen from different corners. So what happens if someone gains control of our computer or gets access to some of our personal accounts? These are actually called the digital attacks. So more formally, a digital attack or cyber attack is any offensive behavior that targets a computer system or information or computer networks or infrastructures or personal computers. And attacks on computers can, for example, breach personal data like credit card information or passwords, or they can expose governmental sensitive data. And cybersecurity, as we discussed previous time, is a set of techniques for pretending those systems or networks or personal computers or programs from cyber attacks. And in cybersecurity, the goal is to protect the security, integrity, and availability of computer systems and data against different threats. So now we introduce a model for cybersecurity, which is called CIA triad. So in this model, we have three points. One is called confidentiality. Here, the other one is called integrity, and the last one is called availability. So in confidentiality, we want to protect data from people who should not have access to them. In integrity, we want to protect data from unauthorized changes, for example, deleting or adding or changing the data. And in availability, we are concerned about having the system or the data that we want available all the time. Because you have seen that, for example, in DOS attack, the system could be out of access. So in availability, the goal is to protect the system from such attacks. So let's go a bit deeper in these three points. So in confidentiality, we are concerned about preventing unauthorized disclosure of information. So for this purpose, in order to provide confidentiality, we have the need to enforce different access rights, which means who can see the data and who shouldn't see the data or use the data. And confidentiality is provided in different ways. For example, having different level of access and setting permission is one way. And the others are, for example, authentication and encrypting data and files. We will talk about this in more detail. So in integrity, we are concerned about the accuracy of the data and completeness of it. So we will have security controls to protect data and not let unauthorized people to change or delete the data. And we want to ensure that the damage can be reversed. For example, if the data was changed by unauthorized people, we can repair the data and have our original data. There are some techniques for providing integrity. For example, keeping backups of data is one technique, and having log the different versions of the data so that if we encounter to have a wrong version, we can go to the one of the previous versions that was correct. And we can use cryptography to securely check for changes. We will talk about cryptography a lot in this lecture. It is the second part of the lecture. And we need to keep track of digital signatures to prove integrity of data. This will also come at the last slides of this lecture. In availability, what we desire is that data should be consistently and reliably available to those people who are authorized. For example, when we log into our social media accounts, first of all, we want to that this login is always possible and the system is not down, and that when we log in, we see all the information that we had seen last time are there and they are available. And how is now availability accomplished? To accomplish availability, the professionals need to always monitor servers and networks and maintain the hardware and software so that they are functioning all the time, make sure that the system is reliable and all the required components are working. And they need to have a plan for disaster recovery before any disaster happens. Let's see some attacks and classify them as a confidentiality attack, integrity attack, and availability attack. So an attack to confidentiality could be that, for example, a hacker gets access to people's credit card info and reveals those information to unauthorized people so that they can misuse them, for example. An attack to integrity of a system can be that, for example, an attacker learns your password and sends email instead of you. So then the hacker in this case pretends that they are in your place and send information instead of you. An attack to availability could be DOS attacks or denial of service attacks that we discussed in the previous lecture, in which the hackers overload the web server or another server or website with fake requests so that that server is incapable of serving its real clients. So now we will see what techniques are required to have confidentiality. The first thing is called, which is very important, it is called authentication. In authentication, access should be, so we know that for confidentiality, we need to have access to the data to the right people and deny it from the wrong people. So authentication is a way to say who are the right people and who are not. So by authentication, a computer can confirm that the users are those they should be. The most popular way of authentication is using username and password. Using username and password is not, of course, the only way for authentication. There are different methods for authentication, and they are classified into three main categories. In the first category we want to talk about here, the authentication method is based on something you have, for example, a credit card. In the next category, the authentication is based on something you know, for example, your username and password. In the last one, the authentication is based on something you are. For example, it requires your fingerprint or it requires your face. So using one authentication method has always some weaknesses. For example, if you use only username and password, the username and password can be attacked, as we saw in the previous lecture. So it is not always safe. So if you have some data or system that is very sensitive and you need to protect it a lot, you need to use several methods of authentication at the same time. This is called multi-factor authentication. So in multi-factor authentication, 2 or 3 authentication techniques are combined together. For example, something that the person uh, mm, is used in combination with something they know. For example, they are asked to enter a PIN code and also to show their face. In the last category, as we have seen before, so it's which is based on the position of some position of something, for example, a secret token or a credit card. Then this can be combined with the two others, with the 2 other techniques or with one of them. So when we fall here, we are using a technique which is based on something you know and something you have. For example, we ask for a PIN code and a credit card, for example. If we fall here, we are using all these 3 categories together. For example, we ask for a PIN code and we ask the user to show their face, and we also ask them to provide their ID badge. So different techniques here for authentication differ from being probabilistic or deterministic. Probabilistic means that the technique sometimes might work and sometimes might not work. For example, you have had experience that sometimes your fingerprint, for example, or showing your face to your iPhone device doesn't work, or maybe someone else can be recognized as you. For example, maybe your twin brother or sister, or maybe even your child might be recognized as you. So there are some cases that the system might not work. So these kind of methods are called probabilistic. But in the 2 other cases, meaning that something you know and something you have, it is always deterministic. So because, for example, when you enter your password, it is either correct or not correct. It cannot be misinterpreted by a computer. Or, for example, whenever you provide your smart card, it is either the right card or not. The computer will know exactly which of these cases is, as opposed to the probabilistic case in which the computer might not recognize correctly. So the first step to have confidentiality was to establish authentication. When you authenticate the users of the system, you can realize who are the users and who are not the users. And you can also realize that, for example, whether or not a user of a system is a system admin or is a simple user, and so on. And then for different roles in the system, you need to have different access control. And for this purpose, different permissions were introduced, which are usually called read, write, and execute permissions. In read permissions, simply the person can have access to data to read them. In write permission, the people can add and remove and change the data. In execute permission, which is the strongest of all permissions, people have the highest permission and can both read and write and, if possible, execute. For example, they can execute the code. In case of a code, when you have read permission, you can just look at the code and see what is inside there, but you might not have the possibility to change it. When you have write permission, you can write a new piece of code or change a previous piece of code. And when you have execute permission, you can run the code. And when you have different permissions, you need to have a access control list, meaning that you need to specify for each user what kind of accesses they have. For example, the system admin might have all these accesses, but the simple user of the system might have only read access. There is a rule here which is very famous. It is called the Bell LaPadula model, and it says it suggests two rules of thumb. It says that we should not have the possibility to read up, meaning that when you have files that have different confidentiality levels, when a person is allowed to read only some lower level, they should not be allowed to read the higher uh, the files in the higher confidentiality level, meaning that, for example, if someone can read secret files, then if there is another file which is in top secret level, they should not be allowed to do that. This is intuitive, but the other one is called no write down. This means that if a person is allowed access to write to top secret files, then they should not be allowed to write to the files below this level. This seems maybe not very intuitive, but this is to protect that the information leaks from top secret level or upper levels to the lower levels. So in order to have access control, besides the different permissions and different levels of access, there is something called isolation, which is also very used to provide confidentiality. In the isolation, we want to not let a program to compromise other programs running on the computer. This is called sandboxing, meaning that each program has its own sandbox, so they will not have access to others. So if one of the programs ruins its own memory or data, whatever, it will not harm other programs. We saw this actually when we talked about virtual machines, that those provide isolation for us, meaning that each virtual machine is only capable of using its own resources, and it will not have access to other virtual machines resources. And if some problem happens, for example, a security issue in some virtual machine, the other ones will not be affected. So we see here, for example, we might have a virtual machine that it happened to have a malware, for example, on it. Then the other virtual machines would continue working normally and will not be affected because of this isolation that virtual machines provide. So having authentication and access control cannot guarantee security of a system because there are other things that we need to think about. For example, the software needs to be reliable, the hardware needs to be reliable. So you might have a very strong authentication and access control for a system, but the software, underlying software is buggy so that it leaks information, or it can be misused so that the information are leaked. So, for example, implementation errors in the software are very important to be checked for so that they do not result in security issues. Now we want to talk about in the rest of this lecture about cryptography. Cryptography provides us many techniques to provide different aspects of cybersecurity, being confidentiality, integrity. So cryptography is actually not something new. It is simply about writing something secretly, and it was an ancient mathematical science, and it was historically used for military communications. So cryptography is the science of hiding data and making it available again when the authorized people want to access to the data. So it comes with two main steps. One is called encryption, which is about hiding the data. And the other steps, which is kind of the reverse of encryption, is called decryption, which is unhiding the data. And we have the notion of cipher, which is an algorithm for performing encryption and decryption. And we have also the notion of key, which is a string of characters used for encryption algorithm or cipher algorithm for changing the data. So that the data after encryption looks like random data. It is not readable. And the key is also used in time of decryption to obtain the original message. So cipher, in this case, is the algorithm, and key is the input to that algorithm so that it knows how to perform the encryption and encryption. Different people need to have different keys for their communication, and their keys need to be unique to them. So for example, when I am communicating with someone and want to have a private communication, we need to have our own secret key, and two other people that communicate, or a group of other people that are communicating, they need to have their own special key, while we might use the same cipher, the same algorithm. So cryptography is used a lot nowadays for ensuring confidentiality of the messages, authenticating people on a network, and ensuring the integrity of the messages. So let's see how we can use cryptography to exchange data securely. So when plain text, which is written here, is the original message that wants to be delivered in a secret way. So imagine this is the plain text. So first, the sender has to use an encryption technique with a key, as you see here, to come up with the ciphertext. Ciphertext is the message that is altered so that it is not readable at all. It looks like a random string. So it is the message that others cannot understand. But then, interestingly, at the receiver side, we can use the decryption method with the key. This key is shared between the sender and receiver. Sorry. And then using the algorithm and the key, the receiver can convert the ciphertext to the plain text. Plain text is the original message, and it can see the original message. So in between, if there are other people that use and that look at the messages that are transmitted, they see only ciphertext. They don't understand anything, what is the content. But it is only the sender and receiver that have access to the original message or plain text. If anyone else gets access to the algorithm and to the key, then they can also convert the ciphertext to the plain text. So this is very important, that the key is always kept secret and in a safe place. So in cryptography, we can have two different categories of keys. The first category is called symmetric key cryptography, which was used historically. In this way, sender and receiver have the same key, so they need to agree on a same key. They use this key with the cipher algorithm to convert from the plain text to ciphertext, or change the ciphertext to the plain text. So here it is very important and actually very challenging to come up with a single key. Imagine it is war and there are military forces scattered geographically, and they need to come up with a single secret key to use for their communication. This is very tricky. They cannot send it just as a letter to each other, because then some people might simply open the letter and know their secret key, and then they can eavesdrop the communication. So it is very difficult, and there are algorithms to share the key between sender and receiver. There is also another approach which is called asymmetric key cryptography. In this approach, this sender and receiver use two keys. One is called public key, and the other one is called secret key. Public key is, as its name suggests, public. Everyone can have access to it. And they use the public key to encrypt the messages. So it can be used to convert a plain text to a ciphertext. But the receiver is the only person who has the secret key. So there are mathematical functions that prepare these kind of key pairs. Each public key has its own special secret key and vice versa. So secret key, as its name suggests, is secret and only the receiver has access to it. And it can use the secret key to decrypt the message, meaning that it can use it to come up with ciphertext to plain text. It is very interesting that no one can use the public key to decrypt the message. It is only the secret key in this case that can decrypt the message. These are all based on sophisticated mathematical functions that provide these capabilities. So let's summarize the differences in symmetric key cryptography and a symmetric key. So in symmetric key, for example, we have just one key. In asymmetric key cryptography, we have two keys. Symmetric was an old technique. Asymmetric is a modern technique. And symmetric is faster, provides a less level of security, but asymmetric is slower, but provides a much higher level of cryptography, and managing the key in this case is much easier than symmetric key cryptography. There are several techniques that use symmetric key cryptography. We will look at some of such examples. One is called substitution cipher. In substitution cipher, each letter in a message is replaced with something else, for example, another letter. You can see here a very simple example in which the alphabetical letters are divided to two groups, and they are written from, for example, number 1 to 13, because we have 26 alphabetical letters in total, and the first number in this group is replaced with the first number in the other group. So for example, we always replace A by N and vice versa. So whenever we have N, we replace it with A. This method is called ROT13. For example, a message that contains hello will be changed to this message. And the decoding or decrement, so this is the incrementing step. So replacing H with, as you see here, with U, and the other letters with their corresponding replacements is called encryption. And decryption is also very similar. You have to find what letter should replace U. So you come here and you see that it needs to be replaced by H. So it is very easy. It doesn't provide a high level of security, although this message does not seem readable, but it is easy to detect that this kind of cryptography is used, and it is easy to then break it and decode the messages. Another technique in symmetric key cryptography is called permutation cipher. In permutation cipher, you divide the text into equal blocks, and your algorithm is to have a random permutation of size E, meaning that, for example, imagine E is equal to 4. So you break your text into chunks of 4 characters, and in each chunk, you permute all the letters according to a key. For example, maybe your key is that replace the first letter with the last letter and replace the second letter with the third letter, something like that. So how do you do the permutation is actually your key, which is secret and only you and the receiver must know. Other people don't know, so they don't know how to decode your messages. So you see here, for example, here we have a plain text. So in order to encrypt the message, you, as I said, break your message to chunks of size E, and then you move them around and have a permutation based on your key. For example, here in this case, the letter in the first place is moved to the third place, and the letter in the second place is moved to the first place, and so on and so forth. So you see in the first chunk, this permutation is done, and in the second chunk also the same permutation is done. Look at these arrows. You see that the same permutation is done. Permutation is simply changing the order of the letters, changing in which order. So you see here we have the same letters, only their order has changed. It is not always easy to come up with how this permutation was done, but it is not very difficult either. So this technique, in its simplest case, as we see here, is not very secure either. There are other techniques that are called DES and the AES. DES stands for Data Encryption Standard, and it was one of the earliest software ciphers. It uses binary keys, but each of them is actually 56 bits long. This showed to be not secure enough either, so then AES was introduced, which stands for Advanced Encryption Standard. It is much secure and is designed to use much bigger keys. For example, keys of the size 256 bits. So how AES works is that it chops data up to 16 byte blocks and then applies a series of substitution, like we saw in substitution cipher, and also permutations, as we saw in the permutation software, based on the value of its key. So it becomes much more difficult to detect. So this technique, being AES, is used on iPhones, it is used in HTTPS protocol, etc. So here is a high-level illustration of how DES and the AES work. So AES takes the plain text and does some initial permutation on it based on its key, and then it divides to two chunks, and then it does some goes through 16 rounds to do some other permutation substitutions, and then it comes up with the ciphertext. In AES, we feed the secret key and the plain text to the cipher, which is the algorithm, and it is much more sophisticated to come up with ciphertext. It has much more rounds and permutations and substitutions. Now let's talk about one of the methods for asymmetric key cryptography, which is called RSA, and it's very popular. It takes its name after the initials of the people who invented this approach. This method is based on factoring of very big prime numbers. And it has, so in asymmetric keys, we have a public key and a private key. So the key which is used for encryption is public. So anyone can encrypt the message, but the key which is used for decryption is private and is only owned by the owner. So in order to use this technique, an RSA user creates two keys, a public key and a private key. It publishes its public key, which is actually produced based on using two very large prime numbers and an auxiliary value. And the prime numbers must be kept secret because they can be used to produce the public key and private key. So no one should be allowed to know them except the person who creates the key. And then messages can be encrypted by anyone. Anyone that accesses to the public key can encrypt messages and send them to the receiver, but the receiver is the only person who can decrypt or decode the message using its private key. So when we have keys in our cryptography, we have the notion of key exchange. Key exchange is actually an algorithm that lets two computers or two people agree on a key without even sending one. Because imagine when you have symmetric key, if you send your key over the internet and anyone can have access to it and can access to the data that you are sending. But there are smart algorithms called key exchange algorithms that actually make you agree on a key, although you have not sent it through a network, for example. This is done by using one-way functions, which are mathematical operations that are easy to do in one direction, but they are very hard, almost impossible to do in reverse direction, even for powerful computers. So far we have talked about encryption and decryption. And now we want to talk about something else which is widely used, and it is called hashing. In hashing, a one-way process or function is used, which takes a piece of data of any size and uses a mathematical function to represent the data with a text of a fixed size. It is important that output of the hashing function has always a fixed size. For example, it can be a string of 4 characters or 400 characters or 100 characters and so on. So the original data cannot be calculated from the hash. So you see here we have the plain text. We feed it to the hash function and we receive a hash text. This function is one directional, meaning that as opposed to encryption and decryption, we cannot go the reverse direction and come from the hash text to the plain text. You might be wonder that why is this useful? It has actually many uses. We will see in the coming slides. So it is very important that the result of each hash function is unique, meaning that when we feed it different plain text, we desire that we get different hash values or hash text as outputs. So this is interesting. When we use it, then we can actually check to see if some documents have been changed or not. We will see more about it when we talk about digital signatures. So hash functions are ideally unique. They generate unique values for different inputs, but they are not always the case, especially if you limit the size of the hash text so that it is very short, then it happens a lot that different plain texts can have the same hash text because your state space is small and the hash function has to map the input to some value. So it is when this value is can have just few cases, it is very common. It is very probable that different messages can have the same hash text. So in this case, it is said that we have collisions. Collisions are bad for hash functions that we desire that they have unique values for different planes. So let's quickly compare encryption, decryption, and hashing. So in hashing, we said we have only a one direction function. Once we compute the hash text, we cannot compute from it the plain text. But in encryption and decryption, it is not the case. So we use the cipher, which is our algorithm, to compute the encrypted text, and then we can use that cipher to decrypt the message, and we can come up again with the plain. And now we want to talk about two cryptography techniques that help us ensure integrity of the messages. One of them is called the digital signature, and the other one is called digital certificate. So digital signature is used to have something like a handwritten signature, but in the cyberspace. So it wants to make sure that the sender of the message is someone we want to be. And it requires a symmetric cryptography, and it is used very much for software distribution, financial transactions, etc. Its main purpose is to provide integrity, meaning that we will make sure that the message was not altered in transit. So let's see how digital signature works. A person who wants to receive messages using digital signatures has to generate two keys, a public key and a private key. And they put the public key somewhere, which is public, and others who want to send messages to them can use it. And of course, they keep the private key private. So imagine Bob here wants to send a message to Alice. They use their, and this is the message, for example. So first of all, they have to compute the hash of this message using a hash algorithm. This is called the digest, and it is here. Then they actually need to encrypt the digest. So they use the public key of the receiver to encrypt the digest. This is called the digital signature. And they send the digital signature with the message. So the receiver will receive both the message and the digital signature. And then what they do is to try to decrypt the digital signature. So the receiver will use their own private key, which is used always for decryption, to come up with the hash value, which was created by Bob. And then they also need to create the hash value using the same hash algorithm. The hash algorithm is not something private. Everyone can know what hash algorithm is used. Then they use that hash algorithm to come up, to calculate what the digest of the received message is. And they compare the both digests. If they are the same, it means that the message was not altered or manipulated on the way. But if they are different, it means that the message is not the original message that was sent. So here it is important to know that the message is not confidential in this case. So having digital signature does not give us confidentiality. If we want confidentiality, the sender, for example, Bob here, has to encrypt the message itself as well. Here he is not doing it, so everyone can read the message, but the only thing which is not allowed in this case is changing the message, writing a new message. So this is just, so digital signature just checks for integrity. If we want confidentiality, we need to have encryption, decryption. That was explained before. So there is an attack that is possible for digital signatures. So we saw that when Alice wants to receive messages, it has to generate two keys and put the public key somewhere that everyone can access. Imagine the public key is here. So so Bob, of course, who wants to send a message can have access to the key, but a hacker can also have access to the key himself. So the hacker can sit in the middle and see what messages Bob wants to send and change them maybe, and send their and use the public key to come up with the correct hash value and the correct digital signature and send a new message to Alice. So this is an attack which is possible in case of digital signatures. In order to solve this, then digital certificates were introduced, which are like electronic credentials, and they are issued by trusted third parties, for example, by banks, by governments. And so digital signature can be produced by anyone, but digital certificates need a third party that everyone trusts and are issued only by them. And they have several purposes. They verify the identity of the user, they verify the identity of the public key owner, and it of course requires that the third party is trusted. And there are several information contained in the digital certificate. For example, the owner's name, the owner's public key, and when it will be expired, and the certificate issuer's name, the certificate issuer's digital signature, etc. So now for sending messages, instead of sending the digital signatures, for example, Bob attaches its own digital certificate to its public key and sends them along the message to Alice. So in this case, an attacker cannot pretend that they are Bob and send messages instead. But the previous attacker could pretend that he or she is Bob. It's not impossible. This is not possible in this case. Thank you very much for your attention. And please ask your questions by email or via forum.